Hello and welcome to your today's webinar. The topic of the webinar is OPC UA, the communication standard for secure and efficient OT-IT integration. And the focus is on the security and the transport mechanisms that OPC has defined. My name is Pavel Sticher. I'm application and support engineer at Softing. Now let's start with the agenda. First, I would like to show you why the OPC communication standards was defined. That means we will clarify the reason for the implementation of this technology. Afterwards, it will be easily for us to understand the advantages of the technology. The next topic of this day is the presentation of the most important properties of OPC UA and OPC, but only regarding transport and security. We will not talk about some services or the OPC UA objects, and also not about the address space, the UA address space. We will also have a look at the most common use cases, and then we will come to the most exciting point of this day, the live demo. The live demo includes the configuration of a secure connection between a OPC client and OPC server, and I will use the gateway from Softing, so-called UA Gate SI. Finally, we will summarize the advantages of the OPC technology, and we will see why OPC is very suitable for data acquisition. I will also present 3 Softing solutions for data acquisition. Why was OPC specified? Well, what did communication look like before OPC? We only will see the advantages of OPC after looking at the situation before OPC. Communication between different applications and different machines is only possible via proprietary drivers. For example, S7 driver for the PLC from Siemens, Ethernet IP for PLCs from Rockwell, and Modbus TCP are used by PLCs, for example, from Vago or Beckhoff. In order to be able to collect data in different applications, you had to develop and use different proprietary drivers. Each application required, depending on the communication protocol of the PLC, a separate driver for each PLC. It was complicated and very time-consuming. The situation with OPC. The first generation of OPC provides a uniform communication interface. But the problem is that the unified communication interface is only between the OPC client and the OPC server. The communication down to the controllers still only works via the interface provided by the PLC. The latest specification of OPC UA, of OPC, so-called OPC UA, defined new possibilities to collect data. With help of this specification, we can finally establish a connection between the OPC client and the machine directly. A big advantage is we can also integrate the OPC server directly in the machine, and the proprietary protocols are no longer used for the communication or to for the communication between the application and the machine. What is OPC UA improved? Which changes make it possible to integrate OPC UA server or other components directly on the machine? We will compare these two technologies, OPC Classic, this is the first generation of OPC, and OPC UA is the new one. The technology of OPC Classic is based on Microsoft's OLE, object linking and embedding. So it was possible, or it is still only possible, to install OPC clients and OPC servers only on Windows. Since many devices do not run on Windows, the integration of OPC server into devices is still not possible. OPC UA extends the previous OPC industry standard with important functions such as platform independence and scalability. Platform independence enables the integration of UA server or components in the controllers. This eliminates the proprietary communications between applications and the machines. The next extension, the scalability. Scalability means it is possible to develop OPC server that have less functionality, but it can be integrated in small devices with limited resources, so-called embedded systems. The OPC specifications defined some kind of profiles, and for example, the profile called Nano doesn't provide any kind of security, for example. Data transport. OPC Classic transfer protocol is based on Microsoft's DCOM. This kind of data transport is not routable and therefore not internet capable. Firewall must be switched off if you want to send data through the firewall, because the port number is unknown. And the security concessions you have to do in the DCOM settings are no longer up to date. The transfer protocol, the OPC UA transfer protocol, is based on the standard TCP/IP protocol. And now the IP layer, for example, provides the routable capability. The TCP layer ensures, using some kind of acknowledgement mechanisms, the reliable data transmission. Reliable doesn't mean secure. This is not secure communication. And you know the TCP port, and this port can you enables, or a defined TCP port enables easy configuration of the firewalls. Now let's have a look on the transport options. Currently, there are two options: UA data to transfer UA data. The first option is the binary protocol UA binary, and the other option, web service protocol UA XML. The UA binary is very fast because it has a little overhead, so you can transfer a lot of data with a small header. Low resources consumption is the next big advantage and very important for the integration in embedded systems. As mentioned, the defined TCP port, usually 4840, can easily be managed in the most firewalls. The UA XML protocol is not as fast as UA binary because the overhead, the header in the protocol is too high. But you can also the port number, and the port number is 80 if you want to use the HTTP protocol and 443 for the HTTPS, so for the secure kind of data transport. This is also good to manage in the firewall. Security concept. In the first generation of OPC, there was no security concept. It was problematic and insecure with the remote connections. If you wanted to realize a connection between client and server, and the client was installed in the one machine and the server on the other machine, you had to do a lot of settings in the DCOM settings, and the data transfer was unsecure. Authentication is not provided, and data encryption is also not possible with the old version of OPC. OPC UA specifies a security model with 3 levels: user level, application level, and transport level security. On the user level, you have the possibility to authenticate using the username and a password, or you can use user certificates for the authentication. On the application level, the authentication also works using the digital signed certificates. The UA client has to send the certificate to the server, and the server has to send its certificate to the client, and the applications has to trust the certificate, and then you can realize a secure connection. On the transport level, you can, using the certificate, or on the transport level, you can send encrypted and signed messages through the network. So let's have a look on the common use cases. The most common use case for OPC is still the communication or the data transfer between machine and various MES or ERP systems. But the relevance for data transmission between machine and machine is increasing too, and the data transfer to the cloud from the machine or from another systems is becoming more important. So now I would like to show you what you have to configure if you want to realize a connection between a UA client, or for example, connection to the PLC from Siemens. I will use Softing UA Gate for the communication and access to the data in the PLC. The UA Gate has a web interface, and I can connect to the configuration. I have to enter the username and the right password. And now we are connected to the configuration or to the device, to the gateway from Softlink. And you have to configure, you have to do 3 steps. First, you have to configure the IT network interface, the communication card. And it is quite easy. You have to enter the IP address, subnet mask, and default gateway if needed. You have to do the same on the machine side. You have also to enter the IP address of the machine side or machine network. But I forgot what. I wanted to show you my structure. My structure is following. I have a PC with a UA client and the network segment with the IP address 1030 and so on. And I have a machine network with the IP address 192 and 168 and so on. And my PLC has the IP address 90. And this is the gateway I'm using to access the data from the PLC. And this gateway has 2 interfaces. The one interface is located in the IT network, and the other interface is located in the machine network. And so you have 2 separated network cards, and this is the first level of security you can use with this gateway. So I'm sorry I forgot it. Now I hope it will clear what I'm doing here in the configuration. So we had configured the IT network card. We have configured the machine network card, and step 3 is to configure the communication from the gateway to the PLC. And it is also easy. You have to know the IP address of the PLC. As mentioned, the PLC has the IP address 192, 168, 1, and 90. I have only to enter the IP address and the gateway establish a connection to the PLC. Now I want to realize connection from the UA client to the UA server. And for the UA client, or the UA client has to know the endpoint address of the OPC server. And I can see the OPC, the address here, and I copy it. Then I will start my UA client. And I will add a session, a connection, and here I have to enter the endpoint address of the OPC server. Now we can validate the connection. And how you can see, there is something wrong. So we have to go back to the OPC server and we have to check the security settings. And here you can see the security settings on the application level. So as you can see, the security mode none is not allowed. You can only choose between sign or sign and encrypt. And security policy, you have also only 2 options. So I can go back to the client and can choose sign and encrypt, or for example, security policy basic 206.56. We will validate the connection again, and the result is the same. So we will go back to the configuration, and now we will check the user level security settings. And here you can also see the anonymous policy is not allowed. You can authenticate using certificate or using username and password. I will try to realize this kind of connection. Anonymous username, PS, validate connection, and it still doesn't work. But I have one idea more. We can have a look in the manage client certificate. How you can see this is the client certificate. The client certificate sent its certificate to the server, but the server doesn't trust this certificate. And now I have to move the certificate to the so-called trusted store. Now I did it. And I hope our connection will work. Validate connection. Yes, we are finally successfully. And now I have a connection to the PLC and I can choose, I can browse the address space and I can choose one value and the value is 66. And I can also write or send data to the PLC, for example, the number 77. And we will read this new value immediately. So this was my short demonstration. We'll go back to my presentation. Summary. We can now summarize the advantages of OPC UA. We can see on this slide why OPC is very suitable for the data acquisition. OPC UA is based on TCP/IP. We can easily, we are here, we can easily transfer data over the internet and firewall can be managed. Platform independence is important for the integration of OPC components in various devices. And hopefully I was able to show you the security concept during my demonstration. And we also have clarified the task of the scalability. Softing solutions. The first solution to collect data is the hardware solution with the UA gate. We saw this solution live in my demonstration. The second solution is a software solution with help of the softing data feed OPC suite. You can also fetch data from several controllers at the same times. The advantage is you can realize more than one connection and you can realize different connections. For example, via S7 protocol to the S7 PLC and via Ethernet IP to a Rockwell controller. If somebody of you prefer the latest Docker container technology, then you can use softing edge connectors for collect data from different PLCs. So, thank you for your attention. Do you have any questions?
Well, I see. Well, thanks, Pavel. I see one question came in with regard to MQTT in comparison to OPC UA. So, what is your opinion on direct PLC data collection with MQTT is it as fast as OPC UA? And the comment here is, I see many people pushing MQTT, but I do not see the value at the device level.
Okay. In my opinion, MQTT is a very good solution to collect data. MQTT is very easy to use. It is also fast. If it is faster than OPC UA, I have not knowledge about this. I can't say anything to the if MQTT is faster than UA, but MQTT is a very good solution. Yes.
Okay. And for the moment, I don't see any further questions coming in. So
I only wanted to say the UA Gate SE
okay.
I have shown you also provide the communication via MQTT. So if you want to use the UA Gate SE, you have the possibility to read data from one PLC, from one Siemens PLC, and you can provide this data via the UA interface, but you have also the possibility to send the data via MQTT to a MQTT broker. So the UA Gate functionality is MQTT publisher.
Okay. Then what else do we have? Will OPC UA become standard on IoT sensors as well, or just PLCs? This is from Claudio Burgos.
A very difficult question. I think a sensor is too small and has very small resources. So I'm not sure if it will be possible to integrate a UA server on a sensor. But a lot of devices, for example, energy meter already includes OPC servers.
Oh, maybe this is one for us. Do you organize also a webinar about softing OPC.NET SDKs? Sure, we can do that. I'll take it into consideration. So our software development toolkits, I'll pick that up. I think that's more feedback in our direction to consider when and if. So I'll definitely record this for us. And I would need to answer that back to Marco Germinale once I've had the chance to talk to the respective product manager. So no further questions at this point. I think we've done a good half an hour together. I hope it's been insightful. Thank you also to Pavel in Nuremberg, and thank you to the participants. And we'll get the documents and the recording to you in short time. And I hope to see quite a few of you back once we do future webinars. Thank you very much. Have a great day and take care. Bye-bye.